Okay, so we have a second derivative using implicit differentiation. The first derivative is fairly easy to find here. We're going to, same thing as before, we're going to do the derivative, but then also finish whatever term we have with either dx dx or dy dx, depending on what we're working with. The first term is 2x. We finish with dx dx because it's an x variable that we're working with, that we're doing the derivative of, and then we add 2y. Right, and then we finish that term with a dy dx because that function has a y in it, right? And the other side is going to equal 0. And this is important that we're going to solve for dy dx. That's the first step. We're going to let this go to 1. That goes away. We're going to subtract 2x from both sides, so we get dy dx equals negative 2x. And then we're going to divide both sides by 2y, so we get dy dx equals negative 2x over 2y, or just negative x over y. And then we're going to treat this as a quotient rule. We're going to take the derivative of both sides, but we're going to be careful to remember that dy dx and negative x over y are interchangeable. So when we do the derivative of this, the second derivative, we get d squared y dx squared on the left side. On the right side, we're going to run through the quotient rule. We're going to bring the top up, right, minus y times 1 dx over dx, right, still using the implicit differentiation rules of finishing, and then minus x times 1 dy dx, and then that's all over y squared, which is the original denominator here. This dx goes to 1, right? But remember what I said up here, right, is that dy dx's can now be replaced with negative x over y. So when we clean up this, we get negative y minus x dy dx all over y squared. Right? But when we replace the dy dx with negative x over y, we end up with well, let's see, y minus x times x over y all over y squared. We get y plus x squared over y squared. To get a common denominator, we get y squared over y, because we need a y in the bottom, and then plus x squared over y all over y squared, right? And here we're going to go all the way back to the original, right? We know that x squared plus y squared is equal to 1, so when we start to simplify this fraction, which is still d squared y over dx squared, we put together these two fractions on the top, we end up with y squared plus x squared all over y. There's a minus sign missing from here. And then this is all over y squared. So this x squared plus y squared is equal to 1, right? And that's from the original statement. And so we can get 1 over y negative over y squared, right? And if we simplify this, we get negative 1 over y times 1 over y squared, right? You flip this second fraction and multiply by 1. And that's how we end up with negative 1 over y cubed, and it all works out.